Now before we start solving اللي هو question number 48, here we have different cases in which we have to basically memorize for the final exam. And I highly recommend everyone to memorize these equations. أنا بتمنى إن الجميع يحفظ هاي المعادلات لأنه راح تسهل عليكم الحل بشكل كبير. طيب في حال حبيتوا تفهموا كيف احنا اشتقينا هاي المعادلات بإمكانكم الرجوع لفيديوهاتي الموجودة على اليوتيوب. عندي في قناة اللي هو lesson 9.7 اشتقيت كل قانون من هاي القوانين بالخطوات والتفصيل للي بيحب طبعا يعرف كيف أنا وصلت لهاي القوانين. طيب الآن الكيسز الموجودة عندنا 1 moving on a flat curved road. To find the speed v is equal to the square root of r times mu s times g. The minimum speed on a curved banked road v is equal to the square root of rg times sine theta minus mu s cosine theta divided by cosine theta plus mu s sine theta. The maximum speed on a curved banked road v is equal to the square root of rg times sine theta plus mu s cosine theta divided by cosine theta minus mu s sine theta. And finally, a minimum or the minimum speed on a frictionless banked road, we will use the equation v equals to the square root of rg tan theta. طيب الآن if we understand the case, we can just directly substitute the values we have in the question in the equation to find the answer. For example, let's take this question, and this is a solved problem in the book. بحكي لنا given a banked road or a banked curve عفوا with a radius of r equals to 110 meters and the banking angle of theta equals to 21.1 degrees, calculate the maximum speed a driver can maintain without slipping if the coefficient of static friction between the track and the tires is mu s equals to 0.60 or 62. Right. Now, we should understand that this is a banked road or a bank curve, and we want to find the maximum speed. So if we go back to the cases, where do we have the maximum speed on a curved bank? This is the equation. So basically, we can simply write down the equation as is. So I can crop this equation, maybe, just to save time. And let's put it here. So this is the equation that we will use to solve this problem. So we can just plug in the values that we have in the question itself to find the answer. So v in this case is equal to the square root of, now the radius of the curvature is 110 multiplied by g, which is 9.81, multiplied by sine the angle, which is 21.1, plus mu s, which is 0.62, multiplied by cosine 21.1 divided by cosine the angle, which is 21.1 minus 0.62 multiplied by sine 21.1. Right. Now, to find the answer for this, let's do the calculation in the calculator together. So we have the square root of 110 multiplied by 9.81 multiplied by sine 21.1, then plus 0.62 multiplied by cosine 21.1, close the brackets, divided by cosine 21.1 minus 0.62 multiplied by sine 21.1. Right. And we find the answer, and the answer is 37.77, as simple as that. So 37.77 is the final answer. So it's equal to 37.77, and the unit is in meters per second. Now, what about the next part? طبعا if you look at this drawing is extremely important, by the way, the free body diagram for this case. الآن, to find in the case of the maximum speed, the force that will keep the car from skidding away while it's curving or while it's rotating is basically the friction force. So it will be pointing towards the center of rotation. This is the friction force. الآن مرة إجا سؤال في الوزارة بيحكي لنا بأنه مثلا نفس هاي الرسمة وكانت عندنا هاي ال N اللي باللون الأزرق مجهولة. And then the question says what is the force in the blue color? We should just say that this is the normal force. Or what is the force in the red color? We just should know that this is the gravitation force. طيب, what is the force in the green color? We should know that this is the friction force. طيب, for example, in this, what is this? This is the net force acting on the car. Or how to resolve the vectors on the x and the y axis. So basically, we should know what is each component and what is basically each vector represent. So let's remove these. Right. Now, going back to the next part, and in the next part بيحكينا and find the minimum speed at which the car can travel with as it negotiates the bank curve. الآن الفرق ما بين المعادلة الأولى والمعادلة الثانية بأنه الفري body diagram, instead of having the friction towards the center of rotation, it will be pointing away from the center of rotation. طبعا how to find the equation or this conclusion, this equation here, you can just go back and watch my videos. By the way, in my video اللي هو lesson 9.7 I guess, I found a mistake that I have done in the substitution. لأنه أنا المفروض إنه ذكرت في السؤال بأنه الميو اس it cannot be 0.62 in this case. Why? Because this is a very big number. يعني فعليا بأنه السيارة حتى لو كانت مايلة it will not slip, it will not skid. ليش؟ لأنه قيمة الفريكشن عالية نوعا ما. So for this equation to work اللي هي minimum speed on a curved bank road, إما بتكون عندي الزاوية عالية يعني maybe 45 degrees or something like that, or the surface has to be very smooth. يعني the coefficient of static friction has to be, for example, 0.05, 0.04. So it's very smooth surface like let's say snow or like ice. فبالتالي أنا وين كان عندي الغلط في المعادلة لما عوضنا الميو اس as 0.62. It should have been 0.066. And this is basically what I found as an answer, but ما بعرف كان في غلط في التعويض ممكن في المعادلة. Anyway, I removed that part حتى بس ما يكون في عندكم confusion. But if you go back to my videos, you will find this equation, the derivation of this equation without the substitution. طيب, what if we want to substitute in this equation or in this question? We have to do a small يعني خلينا نحكي small change in the question. طيب, شو اللي راح أغيره الآن? Let's take the equation as is just to save time. Now we go back here. And as you can see, the only difference between this equation and this equation is basically, if you memorize the one on the top, it's basically the same on the one on the bottom. Here we have positive, negative. Here we have negative, positive, which is basically the same. And instead of writing here 0.62 for mu s, let's assume that, طبعا هذا من عندي. Assume us to be 0.0. Let's say 0.066 for example. Again, why? لأنه لو خلينا نفس الأرقام كما هي في السؤال راح يعطيني error. بطلع عندي الجواب بالماينس تحت الجذر، فأكيد الكالكوليتر راح تعطيني error. لكن mistakenly again بأنه أنا عوضت عندي في الكالكوليتر بإيدي اللي هو 0.066 and I forgot to substitute it in the equation. عشان هيك كان في طبعا بطلع لنا في فرق. Anyway, now let's try to substitute these values in the equation. So V is equal to the square root of, I have 110. So 110 multiplied by 9.81 by sine 21.1 minus mu s. Now we will take it as 0.066, which is a very, very smooth surface, times cosine 21.1 divided by cosine plus 0.066 multiplied by sine 21.1. طيب, if we go back to the calculator, طبعا the only difference we will make is we will go there and we remove this and put a negative or minus instead, and we remove the minus from the denominator and replace it with plus. طبعا sorry. And then we just change the mu s. see if you do equal بيعطينا طبعا ايش error. ليش؟ لانه راح يطلع عندي اللي هو الماينس تحت الجذر and this is incorrect. فبالتالي اما بنزيد الزاويه كثير، طبعا بيكونوا زايدينها في السؤال anyway، او احنا بنقلل اللي هو الفريكشن or coefficient of static friction. So let's make it 0.066. Also let's change this to 0.066. Now we get 18.34, which is basically the answer we've got in the slides. So 18.34 meter per second. So again, the derivation of the equation is 100% correct. The equation itself is correct. لكن كان عندنا في إشكالية فقط في الميو اس by mistake، نسيت إنه أعوضها 0.066 حتى يطلع معي الجواب اللي طلع معي. طيب الآن طبعا by the way مستبعد إنهم يطلب منكم هذا القانون طبعا في الامتحان، لكن it's good to know it. الأول جدا مهم واللي بعده جدا مهم. طيب شو اللي بعده؟ لما يحكينا الآن find the minimum speed at which the car has to move with if the surface is frictionless. لما يحكي لي الآن frictionless، الآن أنا رسمت لكم نفس الرسم. الآن هاي شو راح نعمل فيها؟ كأنه الفريكشن هاي الفريكشن فورس راح تصير صفر، فبالتالي I just have to remove this. And by removing this, what we have left, we have basically the normal force and the gravitational force only acting on the car. The normal force makes an angle which is basically the banked angle which is theta, and we have also the gravitational force. طيب in the case of the minimum speed banked curved and the surface is frictionless, we go back here and what is the equation that we will use? This is the one. The minimum speed on a frictionless banked road is equal to V equals square root of R G tan theta, and this is extremely important. Please try to memorize it. So we go back here and we say now V, the minimum speed, is equal to the square root of R G tan theta. Now we substitute the values. Let's assume that we have the same numbers in the previous question and assume that the surface is frictionless, for example. طبعا cannot be frictionless, it's a NASCAR track. Like anyway, R, let's say that it's 110 multiplied by 9.81 multiplied by tan. طبعا الزاوية 21.1. We go back to the calculator. So we say square root of 110 multiplied by 9.81 multiplied by tan 21.1. طلعنا الجواب 20.4. أما بالنسبة ل question 49 بيحكينا بأنه a car speeds over the top of a hill. If the radius of curvature of the hill at the top is 9 meters, how fast can the car be traveling and maintain constant contact with the ground? طيب الآن the best thing to do is to draw a sketch here, and this is the sketch. This represents the hill itself, and now the car is moving at the top of the hill with the maximum speed. طيب الآن بيحكينا بأنه how fast can the car travel and maintain contact with the ground or constant contact with the ground. بيحكي الآن how fast يعني maximum speed, and the maximum speed there will be a barely يعني there will be barely contact between the tires and the road. راح يكون بالكاد في عندنا تلامس ما بين التواير والأرض. بالتالي at that point فعليا there will be only one force acting on the car towards the center of rotation, which is basically the gravitational force. And we have only F sub G. So in that case, to find the centripetal force is equal to F sub G only. But what about the normal force? Again, we will barely have a contact between the tires and the road. فبالتالي in that case, we can neglect the normal force. So we are only left with what? With the gravitational force. Since the gravitational force is the only force pointing toward the center of rotation, so basically we say that the gravitational force is equal to the centripetal force. طيب, what is the centripetal force? The centripetal force is mv square over r, and fg is basically m times g. Now cancel this by that and then multiply both sides by r and take the square root. We will have v equals the square root of r times g. Now plug in the values that we have in the question. V is equal to the square root of r, which is 9 multiplied by 9.81 And if we do the calculation, I think this is equal to 9.4 meter per second. And this is the end of question 49. طيب الآن ننتقل للجزء 18. طبعا جزء 18 هو عبارة عن جزء مكرر. All the questions mentioned in this part were solved in the previous part. So please go over them and read the learning objectives. فبالتالي احنا تبقى عندنا اللي هو الجزء 19. And جزء 19 we will apply Newton's law of motion and or energy conservation principles to analyze circular motion, a vertical or a horizontal plane motion, a vertical loop of an amusement park ride, rotating cylinder moving through a leveled or banked curve. طيب نيجي الآن إلى الأسئلة الغير محلولة في الكتاب ونبدأ مع بعض في السؤال. عفوا الأسئلة الغير محلولة نعم، ونبدأ مع بعض في السؤال اللي هو رقم 50. A speedway turn with the radius of curvature r is banked at an angle theta above the horizontal. A. What is the optimal speed at which to take the turn if the track surface is iced over? That is, if there is very little friction between the tires and the track. B. If the track surface is ice-free and there is a coefficient of friction µs between the tires and the track, what are the maximum and the minimum speeds at which this turn can be taken? C. Evaluate the results of part A and part B for r equals to 400, theta is equal to 45 and µs is equal to 0.7. So again, we will use the same equations that we have derived before. And بالنسبة ل A, طبعا we will say for sure at A we will say that V is equal to, since this is a frictionless surface, it's iced over, that means µs is very, very small. So there is a little friction, little to no friction. And in that case, V is equal to Rg tan theta. طيب let's go to part B. Part B فعليا اللي هو نفس ايش؟ نفس القوانين اللي ذكرناها مسبقا. So we can take it from there just to save time. And these are the equations. So basically, can crop them as they are. Okay, again, sorry. So these are the equations. We can put directly just to save time because it's basically the same thing. So here, paste. Okay, great. طبعا these are the equations. الآن the minimum speed on a curved banked road, again V is equal to the square root of Rg times sine theta minus µs cosine theta divided by cosine theta plus µs sine theta. And the maximum speed on a curved banked road is equal to the square root of Rg sine theta plus µs cosine theta divided by cosine theta minus µs sine theta. And the difference only minus plus plus minus. You have to memorize this equation please. طيب and in C طالب منا في C إنه evaluate the results of part A and part B for R equals 400 and theta equals to 45 degrees and µs equals to 0.7. So we can basically plug in those values in this equation and in this equation to find the answer. How we can do that? Let's start with the first one. So the first one, the minimum speed, we say that V is equal to the square root of. Now, the radius of curvature is 400 multiplied by 9.81, which is G, multiplied by sine. The angle is given as 45 degrees minus 0.7 the cosine 45 degrees divided by cosine 45 plus 0.7 sine 45. Now what we have to do is basically just plug in these values in the calculator for the first one to find the answer. So here we have 400 times 9.81 times sine 45 minus 0.7 times cosine 45 divided by cosine 45 plus 0.7 sine 45. Of course, the answer will be 26.31. So this is 26 point, guess 41 or 31. Yes, 31. So this is 31 meter per second. طيب. Now let's go to the second one here. We say that V is equal to square root again. And we have 400 times 9.81 multiplied by sine 45 minus 0.7 cosine 45 divided by cosine 45 plus 0.7 sine 45. طبعا we go back to the calculator and we do not have to erase everything, just substitute the minus with the plus. So this is minus, and if we go there, this is plus. And the answer of this is 149.11. So 149.11 is the answer. 49.11 meters per second. And that's it for this question. Now, if we go down, question 51, which is the last question we have in this revision. بحكينا هذا السؤال. The raceway of a car race is banked at an angle of theta equal above the horizontal. What must be the value of theta if a car or a race car moving with a speed of 45 meters per second maintains a circular motion of radius 320 meters, assuming it's raining and the friction between the tires and the road is negligible? So again, this is a banked road and the friction is negligible, so there is no friction, meaning that we have to use this equation. Which equation? V is equal to the square root of r g tan theta. Now, what is the velocity at which the car is moving? It's 45 equals the square root of, now the radius is 320 multiplied by 9.81 multiplied by tan theta. And by the way, we can do it in a different way. We can say that by taking the square for both sides, v square over rg is equal to tan theta. So basically, theta is equal to tan inverse of v square over rg. So we can do this or that. If we do the second one, sometimes we do not get the answer directly, because when we have a square root of tan x, for example, and you do shift solve, sometimes it doesn't give you the correct answer. So anyway, let's use this one to find theta. So we say tan inverse, and make sure that the calculator is in degrees. So tan inverse of v square, which is 45 degrees, or often 45 meters per second. So 45 square divided by the radius of curvature, which is basically given as 320, multiplied by 9.81. And the answer, sorry, this is the bracket. So the answer of this is 32.82. So theta 32.82. And don't forget this is in degrees. And that's it for the revision. هيك احنا بنكون خلصنا كل أسئلة الهيكل، بالإضافة إلى بعض الأسئلة اللي أنا بتوقعها ممكن تيجي في امتحان الفاينل. يعطيكم العافية جميعا، بتمنى لكم كل التوفيق في امتحان نهاية الفصل. السلام عليكم.